The team at the National Oceanographic and Atmospheric Association's Great Lakes Environmental Research Laboratory is responsible for monitoring one of the greatest threats to the blue economy: harmful algal blooms, or HABs. During the summer, the team diligently keeps an eye on the bloom.
Kind of an environmental intelligence of what's going on out there and what do we expect over the next few days.
The goal is to protect the most important part of the blue economy, the water we drink. An HAB poisoned the drinking water for nearly 500,000 people in and around Toledo, Ohio in 2014. And it cost the local economy as much as $60 million. The team has spent their winters perfecting how they track and monitor HABs. Tracking an HAB begins with remote sensing, led by Steve RUBERG and Andrea Vanderwood. Remote sensing starts with images of the bloom taken by satellites high above the Earth. But satellites can't show the whole picture.
One of the limitations that we're trying to overcome, the satellite is, of course, out in space, and it has to deal with cloud cover. In the hyperspectral system, we can fly under the clouds, and we can pick up areas that are closer to shore.
The hyperspectral system is a new technology for tracking HABs. It's a highly specialized camera that is mounted on an airplane. It can fly under the clouds where satellites can't see. Andrea is responsible for interpreting the images.
The wealth of information that you can draw from one image is amazing. You can draw not only geology, but biology.
The hyperspectral system uses bands of color to determine if a harmful algal bloom is present. The system can also detect HABs near the lakeshore, where satellites often can't spot them.
If we can give people advance notice about these blooms, they're going to be much more prepared to deal with them and not have a situation where you have to shut down a water intake.
Advance notice is provided by Mark Rowe and Eric Anderson. It starts with predicting how the water is moving in the lake.
In a similar way as the weather is forecasted through observations and modeling, we do the same thing for the water, and we call this hydrodynamics.
Hydrodynamic modeling is combined with information from the remote sensing team to produce the HAB tracker.
It provides a real-time nowcast, which would be like the best estimate of the present distribution of the bloom. And then it also provides a forecast 5 to 10 days into the future of where the bloom is predicted to move.
There's one crucial piece of information that's missing from remote sensing and modeling. That's provided by Tim Davis and Tom JOHENGEN on the monitoring team.
We measure toxicity, and we collect samples for toxicity, and that's something that at this point we cannot estimate using remote sensing techniques.
For the monitoring team, looking forward means looking back.
We still are evaluating our data in terms of understanding how the lake is responding to water quality changes. We're also improving our instrumentation, adding new sensors, trying to better calibrate those sensors so that we understand their response, that we can interpret those results better.
The bloom in the lake may be dormant for the winter, but the team that watches it isn't.
Just because the blooms in Lake Erie and the rest of the Great Lakes slow down doesn't mean we do.
For more on the Great Lakes and the blue economy, please visit greatlakesnow.org.